Welcome to our podcast. Today we are talking passive house design. Listen to a compilation of 3 past podcasts featuring guests who are making a big impact in sustainable architecture. Kirstie Wulf, Ashleigh Horne and Marisa Coram with David Hellier talk about shaping eco-friendly spaces, from hemp construction to off-grid houses. Join us as we explore their inspiring journeys in changing the way we think about sustainability and housing.
Welcome to the podcast today. Today we've got a special guest, Kirstie. So if Kirstie, you want to do a bit of introduction and tell people about yourself and give us a bit of a rundown. What do you do?
Hi, yes, so I'm a building designer. I work for my own business, which is Shelter Building Design. I've been doing that for almost 10 years now, and I specialise in natural building materials, particularly hempcrete, but I've also done quite a lot of other ones like straw bale, light earth, earth bag, those types of things. I'm also a passive house certified designer, and I have my first hempcrete passive house currently under construction in Sydney, and also do quite a lot of work in high bushfire areas and work with a lot of people who are obviously off-grid.
Exciting. Yeah, I'm very excited, like I said, to have a chat with you because it's what I find, there's a lot of passive house consultants I've talked to. They've got a way that they want to build houses, and I think I would love. Have you ever put a blower door test on a hemp house, or have you ever put a blower door test on any of your sustainable houses you've built?
Not yet, but obviously with them being certified passive house, I will. So the first hemp place I did was my own house, and that's sort of how I got into it. So on the south coast of New South Wales, I built my hempcrete house. That was started in 2012 and finished in 2014. So at that time, hemp building was quite early in Australia. I'd say we're probably one of the first 5 houses built in Australia. But that house, in terms of its functionality, we have no heating and no cooling, and it stays comfortable all year round.
Exciting. So I suppose just to explain to people that are listening, what is a blower door test? Do you want to explain to people what that test is for the passive house design?
So in terms of blower door test, what they're looking at is they're looking at the air tightness of a house. So most houses in Australia aren't airtight at all. So whatever heating and cooling we are doing, we are losing it through all the cracks and gaps and those sorts of things, with in winter cold air coming in, or in summer your cool air going out. So the idea behind sort of air tightness is that it's one of a number of strategies to increase the efficiency of your house by stopping all this heat transfer inside and out from those cracks and gaps. So a blower door test is basically they will close up all of the windows, seal up all of the doors, and in one of the doors they'll put a blower door sort of unit, and it will either pressurize or depressurize the house and work out how many air changes per hour are going through the house. So most Australian houses are pretty shocking, somewhere about probably around 12 air changes an hour. So obviously working to improve that. The passive house standard, it is got to get down to 0.6 of an air change per hour. So obviously a huge difference there. In terms of health though, once you start sealing houses up, you need to start looking at how are you going to get fresh air into the house, because once you get below about 3 air changes per hour, for health reasons, you need to introduce some sort of ventilation, and the most efficient way to do that is via mechanical ventilation with heat recovery, because what that means is that whatever the temperature, and when I say heat, it can be hot or cold, depending whether it's summer or winter, you have in your house, it will strip that out of the outgoing air and add that to the incoming air to keep that whatever temperature you have in your house even. So there we go.
Yep. No, thank you. Yeah, it's I'm excited. I really can't wait to see your the results from your hemp house, because I think with a lot of the inefficiencies with building, it's the thermal bridges and putting everything together is where all the problems come from. And hemp, you've got your formwork, you pack it in, and a lot of that a lot of the things from traditional building just gone from building with hemp and rammed earth and things like that.
Yeah, so one of the things is actually I came into sort of looking at passive house from a background of natural building materials and working with hemp in particular. And from the way I was looking at things, hemp sort of lends itself quite naturally to a much more airtight building. Because the hemp is cast on site, what it means is that you obviously from the start, the way the building material goes together, we're reducing a lot of those cracks and gaps to begin with. So I actually went in to study passive house design on the basis of trying to sort of say, look, we need to be able to do our natural building materials better. And I think that these natural building materials actually can perform as well or even better than a lot of these sort of petrochemical based insulation materials that they're using to get the high insulation values they require for passive house.
Yep. No, definitely. So how did you get into the industry? Like, yeah, when did it all start?
Interestingly, about probably 22 years ago, I sort of a builder. I was sort of involved a little bit in my first house, which is a mudbrick house in the Blue Mountains. So at that point in time, my building knowledge was quite minimal, and it was a pretty steep sort of learning curve. Most of it did pretty well. Put all the windows on the north side, so we had a good start there. But obviously, could have done a little bit better. So that sort of really, once just going through that process, made me realise that I really liked building. You know, it was kind of like going back to being a kid and building cubby houses, which is one of my great sort of things that kept me busy for days as a child. So I was sort of involved in that. But at the time, I was actually working as a lawyer and continued doing that for quite a few more years. I did study building design, but then had a child, so that sort of made it easy to go back to lawyering rather than start a new career. But I started building my hempcrete house on the south coast, and I did that as owner builder. So I did a lot of work in that, and it was through that process that I really sort of felt that my sort of passion was building design and that I had to do it. So I did some further qualifications and started my own business.
Awesome. Very exciting. I just actually might share your website here. And you had a few different builds here. So do you want to explain the differences, with the hemp, mud brick, light earth house? Like, what's the meaning behind them?
Okay, so basically they're all referring to, and it's interesting that the only difference is really the wall material. So people often sort of refer things to as a hemp house or a mud brick house, but really it's just got walls. The rest of the house is all sort of can be quite sort of similar. In terms of that, so mud brick is a very ancient sort of way of building, whereby a clay-rich soil is formed into bricks and usually just sort of dried in the sun. Very low embodied energy, really easy to sort of use if you have the right type of soil. You can dig that subsoil from your site. Mud brick can be a little bit labour intensive, but really sort of versatile building material. Although a builder did build my mud brick house 22 years ago, I did my own mud brick shed, which taught me actually how heavy mud bricks are. So in terms of that, mud brick is a high thermal mass material. In other words, it will take a while to heat up and a while to cool down, but it will hold that temperature. So it's a good choice where you have a high diurnal sort of change in temperature. So hot in the day and cold at night, it can really act to sort of even that out. However, in climates where you have like a long string of really cold days or a lot of heat where it doesn't cool down at night, that thermal mass can actually sort of act against you. And in really cold climates, it doesn't really give you enough insulation. And so that was why when I actually built my next place, which is on the south coast, I was looking at doing hempcrete. The reason that I chose the hempcrete was, as an owner builder, it was easier for me to do. Part of the reason for that is that there's a standard timber frame inside the hempcrete. So as a bit of a novice, I was relieved to know that, the house wasn't going to fall down. The other thing is I investigated the insulation values, and that was one of the downsides of my mudbrick house, was that it just didn't get warm enough in winter. We did have to use artificial heating. So nice and cool in summer, but not quite warm enough in winter. So I looked at the hempcrete on the basis that it was going to be much better in terms of insulation, but also in terms of vapor permeability. So that's one of the great things about lots of natural building materials, is that the walls are vapor permeable. And people often sort of say that the walls are breathable. Air is not going through there, but water vapor is, because the water vapor is smaller. Why is that important? Because having an even indoor humidity level is really important for our health, to reduce mold. And so by having a vapor permeable building material, it really provides both even temperature and even humidity. So that was kind of my reasoning behind the hempcrete. Looking at also light earth. Light earth is a great choice for high performing natural building material. It is a little bit like hempcrete in the sense that there is a standard frame which is your structural support. And instead of in hempcrete, it's hemp and lime, which is the infill. In light earth, it's straw and clay. So unlike cob, which is also straw and clay, but cob is mostly clay with a bit of straw, light earth is mostly straw with a bit of clay. And so the clay just sort of acts as a binder.
Yeah, cool. So I think I was just actually trying to find a photo of you. So I thought I saw a photo of you doing a straw bale house. Was correct?
As a building designer, I was designing a straw bale house, and took myself along to a workshop building a straw bale house. So I've actually just done sort of volunteer work on a number of straw bale houses. And for me as a designer, I feel like understanding how the materials go together and what all the pieces involved, all the steps involved are, it helps you understand how you can design them so that they're easy to build. Yeah. And sort of also assisting sort of owner builders who are then doing that sort of work.
Yeah, definitely. Yeah, for myself, when I first got in the solar industry, that was, I suppose, for me, it was a logical thing to do. That I wanted to sell solar systems. I went and worked for a year doing installations and learning how to do the installs and all the ins and out of it, and how it all worked. And I think there's a lot of people these days that just don't do that stuff and just want to sell it, or they don't really live it or understand it. So I can see how valuable that is, going out and building.
I think that having had the experience of building my own house, sort of like from woe to go, it really sort of just helped me understand sort of all the things that owner builders themselves might be facing, and looking at also discussing with people what skills they have in terms of their owner builder journey, what they contract out. So I think that whole experience was quite invaluable for me.
Okay, guys, so today we're actually talking to Ashleigh Horne from Wingham, and Ashley's going to share about the process and being involved building with hemp.
Yeah, well, that was another thing we liked, was that we actually, because we don't have building backgrounds, but we liked that we could actually be involved in the build of these houses. So you put up formwork on either side. It's a standard timber framework house, and you put up formwork, which is these blackboards on either side of the timber framework. It ends up having we've got ours at a 200 mil gap. And then you fill the hemp mixture in between the boards. So you use a mortar mixer, you add hemp, lime, some sand and water into a big mixer. It's sort of like a slurry. It's not, how would you describe it? It's almost like soil, I guess, in texture. Like, it's loose. It's not wet like concrete. And you just lightly tap it down when you put it in between the formwork and you go around your timber frame. So it helps protect your timber frame over the long term, because rodents and insects and termites can't get to it as easily. And after about 12 to 24 hours, you can take off this formwork and you just make your way around the house, really.
Yeah, awesome. And so you guys, by the looks of just you chose to not render the inside of the house and just left it natural?
Yeah, so we just fell in love with the marbled look of the hempcrete. As you go, it tells a bit of a story. So we have rendered it in sections of their house. So the kids' bedrooms, for instance, we have done a clay render on their bedrooms. Only because leaving it non-rendered on the inside, it is a soft wall. So if a kid got really frustrated or they're a bit rougher on the walls. So in the living dining areas in our bedroom, we've left it exposed. But yeah, just in the kids' bedrooms, we've put a render in just to make it a bit tougher for them.
Awesome. Yeah, so it's a great finish. It'd be hard choice for me whether what to render it or leave it. So
yeah.
They both look amazing.
And the render looks beautiful too. The render's it's a lot smoother. You don't get the lines. They both have beautiful aspects.
Hey guys, Mike Hayden here. Today on the podcast we have David and Marisa. So guys, tell us a bit more about your business.
So our business is, our mission or our vision is to make passive houses or energy efficient, sustainable, healthy houses available to everyday people. And we are constantly looking at different ways to do that. At the moment, these kind of houses are normally only built by somebody who can afford an architect or a building designer with bespoke designs. And that's not the majority of the population, but we believe that everybody should have these kind of houses that far outperform the traditional builds that most people have built for them. And so we're on a mission to make that happen in both in urban environments and in very remote communities throughout Australia.
Yeah, so before we were talking about, you guys have looked at a couple of off-grid properties before. Tell us a bit about those situations and what happened and the reason that they didn't end up going off-grid.
The reason that they didn't end up going off-grid, this is from experiences of mine prior to starting this company and with involved in traditional builds. And the reason they didn't go off-grid essentially was because to the amount of energy required to run a standard, if you like, family home of, let's say, 4 bedrooms, 2 bathrooms, that sort of thing, or maybe a bit bigger, was that you need quite a lot of solar panels. And these were semi-urban sort of situations, so they have large block but not a big country property, and they just simply didn't have the room to be able to set up enough solar panels that they'd be able to efficiently run the house.
Yeah, it's definitely a big challenge. I know for me, the first time I went to take my house off grid in the middle of Sydney, and that's all I kept getting told, that you can't do it. And no one told me the reason why. And I spent years getting quotes and wanting to do it, and everyone just said, you can't. And then, I just realized one day a guy said to me, you just use too much energy. You just don't have the roof space to produce enough energy. And that's why I'm on a mission to make my house energy efficient. And it was a retrofit. The house was already there. And from designing and building retrofits can be very expensive to retrofit to make energy efficient.
Mm-hmm.
So we went down that path and made the house really energy efficient. And we ended up going off grid with a 3 kilowatt solar system at the end of the day and 12 kilowatt hours battery storage. So it was actually a really little system in the scheme of things. And if I had my time again, I would definitely put a bigger system up, more solar panels, and done it that way. And one of the biggest challenges we had that house, we were lucky in winter, we had a fireplace to heat it. And in summer, we had an abundance of solar, so we could easily use the aircon and get away with that there. So tell us more about so what is someone listening at home that doesn't really understand that passive house or a passive house designer? Tell us more about that passive house process.
Okay. Do you want to take that one?
The process is you engage a passive house designer at the early stage rather than at the end of your design cycle, so that you can understand the energy loads and demand of the design that you want prior to going into detailed design. So the passive house designer has been trained with an energy model that is a big spreadsheet, multiple inputs into the spreadsheet, which go down to the very detail of the building's windows, shading, the area, the number of occupants, its climate region, all the appliances that are used in the building. All of this is inputted into the energy model, and it outputs the amount of energy that is needed on a daily basis to keep its temperature between 20 and 25 degrees. And it has a requirement that it uses less than 15 kilowatts per meter squared per annum, right? So I built a certified passive house in Sydney of my own. The model told us it would use about 8.8 kilowatts per meter squared per annum. And what that actually means in reality is you only need 4 solar panels on the house and a battery, and you will run it pretty much off grid.
Yep. Awesome. So how long ago did you build that house?
That house was finished in 2020. So we were the second certified passive house in the state.
Awesome. And have you got to keep have you seen the electrical data, exactly how much energy it did use after it was built?
I did. We were monitoring it because I kept it while we were living in there. We kept it well below 15 kilowatts per meter squared per annum. It's an average of 15 kilowatts per meter squared per annum. In summer, we would probably hit 15 when we were running the air conditioner. In winter, we probably went around 8.8. And we wouldn't even need to heat the building at all.
Yeah. And was that an all electric house, or was it gas cooking, gas hot water?
We went all electric. So we totally disconnected from gas, got rid of that energy bill every month, and that also worked out really well.
Yeah. And so if I was, to build a house like that, how much extra per square meter would have been paying? Did you do those numbers compared to just doing a traditional build?
It's really hard to compare this, because if you're talking about a volume build, it's not going to compare favorably. If you're talking about an architectural build, we would be we actually told our architect at the time it has to come in at less than the neighbour's architectural house, which it did.
Yeah.
It also depends on what materials are used to build the house. So, because there's various different ways. You can stick build a passive house, for example. Our company, however, is a panelized system, panelized or modular system. So that's one of the other benefits of this way of building is, it's precision built because it's all manufactured in a factory, all the panels, and so rather than having lots of different trades where there's lots of room for human error, everything's precision cut with machines, and then it's delivered on site either in a modular form or in panel form, which then goes up in the space of a couple of days. So it greatly reduces, it increases the quality of the build because it is precision built. You don't have weather delays because it's been built in a factory, so it doesn't matter if it's raining or what have you. And then it's put up in a couple of days. So that's all, in terms of this is why it's a little bit hard to, or one of the reasons it's hard to compare it to a traditional build, because there's all sorts of savings that go along with that. So, if you're renting while you're building, if you only have to rent for 6 months rather than 18 months, then you've got a year's savings worth of rent. It also, like I said, depends on what it's being built out of. Like David's house was built with CLT, cross-laminated timber, which is probably one of the more expensive ways, if you like, to build the panels. But they can also be built with timber frames and OSB board, which is cheaper. And it's just as effective. You just don't get the lovely CLT timber interior.
Yeah, you'll have a very nice house either way.
Yeah,
you'll have fresh air coming through, filtered air coming through. There'll be no mold growth, that sort of thing. So
if you take everything into account, and the fact that you're likely to have no electricity bills, and all the savings that go along, or the ongoing savings, there's less maintenance because they're because of the way they're built and the humidity is controlled, they're mold free. And mold is not, so they're very healthy, but mold also attacks the fabric of the building, which leads to repairs. The fact that it's precision built leads to less repairs because it's very like in square and that sort of thing, and doesn't move as much. So if you take all of these into account, it's kind of hard to say whether it would over time be less than a traditional build or around the same, but the price gap is coming down all the time, and that's one of the things that we are addressing in a few different ways. And we're working towards having a mega factory, smaller factories at first, and then a very large factory. And once you get to that level, the cost is less than a traditional build. So it's a scale kind of a thing. In saying that, though, it's not, while it's a bit more expensive than a traditional build, it's not like double the cost of a traditional build or anything like that. And like we're saying, the cost savings that you get from this way of building pretty much would make up for any initial cost gap that there is, and a lot less stressful as well.
So I can expand a little bit. Like the passive house designers have told that you can get it at the same cost as a traditional build, up to 15% more. The variances will be climate dependent, house dependent, occupant dependent. Really comes down to the design. Where we are coming in to actually save on the cost is for those who cannot afford an architect, right? So architecture fees and building designer fees are quite expensive. What we've realized, though, is architects and building designers have a back catalogue of plans that we can actually create available to everyday people. So if you've got a plan already as an architect or a building designer, you want to monetize that and create a recurring revenue stream, get in touch with us. We'll be able to put it on our marketplace, and other people can start to look at it and say, yeah, that one actually suits my lot. And secondly, those designs have to be designed for offsite construction already. And if they're designed for passive house, even better, because then we don't have to do any extra work, right? So that's the first cost saving. The second cost saving is in when we start to think about, as Marisa already said, that when we get to large scale and to do mega factories and wholesale prices become cheaper, everyone benefits, even those who are at the bottom of the market and those at the top of the market, right? Third thing, the National Construction Code is actually gone up, and at the last year, NCC 2022 was introduced. From 1st of October, every home in New South Wales at least has to reach the 7-star BASIX level. So the price gap is actually decreasing, because 7-star means that homes will now start to have double glazing by standard. Their wraps, beefed up insulation, their wraps will be better, but still there's a big gap between what 7-star produces and what passive house produces.
Not big cost gap, but big benefit
gap. Absolutely.
Yeah. I'll tell you a story, and I think you guys could really help out. And so, and the reason someone would probably engage a passive house designer in a project, and me thinking I know everything. When I did my house, not that I wouldn't have engaged the passive house designer from the house. So when we did the build, we did double glazing windows and magnesium oxide board insulation. I had all this stuff done. Talked to the builder about all the insulation, and I'll tell you the problem that happened. And if you guys can help explain to the listeners at home of how a passive designer would have helped this problem being fixed. And I remember one day coming home, and double glazing windows is in, and there's like 100 mil gap between the window and the stud, and they didn't put any wrap in between it. I said to the builder, mate, why can I see sunlight through that there? He goes, oh, I'm going to tape it up and fix it up later on, blah, blah, blah. I said, you make sure you tape that up. Like, it shouldn't have been that wide anyway in the gap and the big air through there. He's like, yeah, mate, we'll sort it out. So anyway, months go by, and, you know, I got home the next time I saw that, and there was, you know, architraves on the window. Months go by. Later on, I come home and I open my front door, and this is literally the sliding doors out the back. I see sunlight straight through the architrave. And I called him and said, you didn't tape that window, did you? He said, what are you talking about? I said, mate, I can see sunlight through the architraves. He's like, no. I said, yeah, I can. I sent him a photo, and he's like, oh. And he doesn't want to come back and fix it, basically. So for me now, every winter I get the heat gun out and, you know, the thermal imaging camera, and I can just see the cold air coming through. So I've spent all this money on double glazing and making this house amazing, and they've left a 100 mil air gap next to the window. So if I had a passive house designer engaged in my build, how would that have helped and stopped that from happening?
Well, the window, again, going back to it being precision built in a factory. So the windows are installed in the panels prior to delivery, and it's all precision cut in a factory. So you're not having that. You're taking away that possibility of human error and things not being quite square building on site, and then you put the window in, and because it's more likely that it's the window frame that's out than that the window's crooked, and so you're getting rid of that sort of possibility, and then the whole building envelope is wrapped in an airtight wrap, and so.
The third level of quality check is
tape,
the tapes as well. And then the third level of quality check is there's a blower door test at the end of the whole lockup stage, which will
identifies
tell you if
those leaks.
And you can say, I don't accept this. This is no good. It needs to be below 0.6 if you want a passive house. Now, with the new National Construction Code, if you build a house more airtight than 5 air changes an hour, the builder will actually try to make it more leaky deliberately, because otherwise they're forced to put in a ventilation system.
Yeah.
So you're stuck in this two mindsets of it has to be leaky because it needs to be ventilated, and he'll probably come back to you and say it has to be leaky in that case, right? Because you didn't ask for a passive house.
And so there's also too with the windows and doors and everywhere, they're all thermally broken. So any thermal bridge, which a thermal bridge is any point in the house where that transfers heat and cold easily, which windows are a big one that does that. They're all thermally broken, which means that you're not getting that transfer of heat, and so it's not pulling the cold air in through these thermal bridges in winter, for example, or pulling the hot heat across these thermal bridges. So I guess someone who's not aware of these things, not trained in passive house, and doesn't build in that way, a normal builder, it's not to say they're not a good builder, but they just don't think about these things, because it's not the way they've been trained, and they quite possibly don't understand how the impact that has, those thermal bridges.
Totally. It's one thing I always tell people: the best money you can spend is the design of your house and making it energy efficient. And I think there's a real big disconnect from the designers, when I say a traditional designer, through to the end user, because, you know, for me, I suppose, I'm in a unique situation. I'm involved in nearly every project we've ever done. It's been a new build. So there's always, you know, customer builds a shed and then they build a house. I've been able to influence on that way to make the house energy efficient and add value on that way to, you know, and at the end of the day, I have been a bit selfish, because the more energy efficient their house is, the better performing the solar system is going to be, because the less it can heat or cool, the better the system's going to look. So that's why I've been very fortunate over the years to help and get involved in that design process. And I always tell people the best money you spend is on making the house as energy efficient as possible. Well, guys, thank you. I really appreciate your time. We'll put your contact details down below if anyone wants to reach out and have a chat. And thanks. We'll see you next time.
Thanks, Mike. Thank you.
Thanks, guys. I hope you enjoyed this episode and found the content educational and inspiring. If you got something out of it and you think you know someone else that would actually also enjoy it, we'd really appreciate if you could share the link with them and encourage them to check out our channel. And don't forget, you can join the OffGrid Tribe podcast for free, where you can actually ask and interact with myself and also our guest speakers. So jump over today to offgridtribe.com, register yourself an account where you can actually have a conversation with myself and one of our guest speakers, and we can continue the conversation there. Together, let's embrace the power of sustainable living.